excellent performance. With this technology, you can build almost anything you envision and produce it at scale. Impressive. Oh, there's also an anti-drone vehicle here. Let's take a look. This vehicle features a high level of system integration. At the front of the vehicle, you can see a square panel. This is the Ku-band active phased array radar with a detection range of about 10 kilometers, capable of effectively identifying various low-altitude, slow-moving drones. On the side of the rear platform, the lens you see belongs to its photoelectric detection system. When radar is unavailable or operating under suboptimal conditions, this system provides an effective supplementary method for detecting aerial targets. Mounted on top is an electromagnetic detection antenna, which identifies and tracks drones through their electromagnetic signals. Although it looks like an ordinary vehicle, this system is actually designed specifically to counter drone swarms. The onboard radar at the front provides a 10-kilometer detection range, essentially giving the vehicle eagle-eye vision. The photoelectric camera handles tracking and can take over when radar performance is limited. The electromagnetic detection antenna on the roof captures drone communication signals. With radar, photoelectric, and electromagnetic detection working together, even small airborne targets have nowhere to hide. Looking at the vehicle as a whole, once all these systems are installed, it carries a distinctly capable and authoritative presence on the road. Let's take a look at the interior. Quite impressive. Independent aviation style seats, large triple displays, and a wide-through type dashboard with wood grain trim. With a vehicle this refined, wouldn't you want one yourself? So how would you operate it once you bring it home? Let's take a look at its human-machine interface. The center screen primarily displays the radar interface. At the top of the screen is the photoelectric imaging. The left side shows the visible light feed, and the right side shows the infrared feed. The lower section displays the electromagnetic detection interface, which identifies drone communication signals across different frequency bands. The three large screens feel like the cockpit of a sci-fi racing simulator. The radar interface provides situational awareness, the photoelectric system offers day and night imaging, and the electromagnetic detection monitors drone signals like a stethoscope listening to a heartbeat. When drone swarms fill the battlefield, traditional air defense systems can be costly and slow to respond. This mobile anti-drone vehicle acts like a surgical tool, precise, flexible, and cost-efficient. And for those who say, "My budget is limited," are there more affordable options? You can consider this portable anti-drone device. This is an anti-drone decoy device. Although shaped like a gun, it works by emitting directional electromagnetic signals to interfere with or mislead drones. Despite its appearance, it produces no recoil, and precise aiming is unnecessary. You simply point it in the general direction of the target. And if you're not attached to the gun-shaped design, you can opt for this backpack-style anti-drone system. It consists of two parts, one worn on the back and the other held in the hand. With this small backpack, you can effectively engage drones with ease. There are currently three main modes of operation: force landing, repelling, and decoying. Force landing sends a signal that triggers the drone to execute a landing command. Repelling directs the drone away from a protected area. And decoying injects false control signals to guide the drone to a designated location for landing. In this way, you can safely retrieve the drone once it lands. Vehicles serve as heavy-duty tools for countering large drone swarms, while handheld and backpack systems act as lightweight equipment suitable for individual operators. Decoying, force landing, and repelling are all achieved through signal manipulation, sending false commands to drones in flight. These refined soft kill techniques form an invisible defensive net, and when combined with hard kill methods such as lasers or anti-air missiles, They create a comprehensive, multi-layered air defense system. From sky to sea and across land and air, unmanned systems have become essential components of modern battlefield operations. How do unmanned systems understand the seabed environment? How do they detect new underwater activity? Take this unmanned submersible as an example. Enhanced by AI. Here we have a CNC machine tool. With AI integration, it can handle a wider range of pattern holes and achieve higher precision in process components. As a manufacturing nation advances toward high-end intelligent manufacturing, the application scenarios become increasingly diverse. These technologies are not only valuable for industrial production lines, but also highly relevant in defense applications. With equipment this advanced, who wouldn't want to build one? As we witness how technology is reshaping future battlefields, military fans travel the world continues its coverage of the Chengdu National Defense Science and Technology Industry Expo. But on the other side of the exhibition lies an even bigger topic. How are all these components actually made? Compared with previous editions, this year's expo places deeper emphasis on integrating the innovation chain, industrial chain, and supply chain, making intelligent manufacturing one of the most prominent themes. For Dong Shihong, a military blogger deeply involved in defense manufacturing, this is where the true foundation of military capability begins. China has been one of the world's leading manufacturing nations for more than a decade, and today its industry has moved beyond simple made in China into a new era of intelligent manufacturing. So today, let's take a look at the strength of China's manufacturing sector. In front of us is a CNC machine tool, but this is not an ordinary CNC machine. It is enhanced with AI. To ensure machining accuracy, traditional CNC machines typically rely on constant temperature environments. However, the CNC machine displayed here solves the issue of thermal expansion and contraction directly within the machine itself. With AI integration, it can handle a wider range of pattern holes and achieve higher precision in process components. Machine tools are like industrial carving knives, shaping metal blanks into precision parts. But metal has its own characteristics, namely thermal expansion and contraction. In summer, when factory temperatures rise, the machine tool expands, causing deviations in the parts it produces. Traditionally, factories install constant temperature air conditioning systems, which are costly to build and maintain. This AI-enabled CNC machine is different. It has an internal smart brain that senses temperature changes in real time and automatically compensates for errors through AI algorithms. Whether in hot or cold environments, the precision of the machine parts remains consistent. Two automated guided vehicles, AGVs, are also on display. The upper one runs on rails and slides along a fixed track. This is called an RGV. The lower one is trackless and can navigate autonomously. This is an AGV. Notice how low the chassis is. This low-profile design makes it ideal for special scenarios, such as transporting materials in factories. Here you can see a LiDAR sensor, and if you look at the opposite bottom corner, this is an obstacle avoidance radar. Each radar covers 270 degrees, meaning for radars at the four corners provide full 360-degree coverage, giving the vehicle excellent ranging and obstacle avoidance capabilities. Rail-guided unmanned vehicles operate like subways, ideal for fixed routes. Trackless unmanned vehicles navigate like taxis, suitable for flexible and dynamic scheduling. To vehicles, one capable of towing up to 800 tons and the other 20 tons work together like autonomous porters in a factory, automatically delivering materials along the production line to their designated locations. In the past, people pushed and pulled carts. Now machines handle the work on their own. These heavy-duty automated transport vehicles have a wide range of application scenarios. They are not only useful for industrial production lines, but also highly valuable in military settings. For example, in ammunition factories, where material handling is dangerous, unmanned transport vehicles can safely move weapons and ammunition. In future conflicts, they will be able to plan routes autonomously, operate independently, and assist in loading heavy equipment. Intelligent logistics functions like the circulatory system of a smart factory, connecting isolated production steps into a seamless workflow. Today, such systems are widely used in aerospace, defense manufacturing, metallurgy, chemical engineering, machinery, and other industries. The intelligent manufacturing ecosystem at the rear directly supports frontline intelligent logistics with key technologies. From unmanned systems to intelligent manufacturing, this exhibition allows military enthusiasts to witness China's independent, comprehensive, and intelligent defense technology ecosystem, as well as the deep capabilities of a technologically advanced industrial base. From frontline equipment to rear area factories, AI and unmanned technologies are reshaping every link in the chain. China is steadily advancing toward high-end intelligent manufacturing with an innovation-driven, forward-looking approach, demonstrating its contribution to peaceful development through real technological strength. On the modern battlefield, why do messenger pigeons still cross the line of fire? Military pigeons can maintain stable communication even in complex electromagnetic environments and blend naturally into the surrounding wildlife. How can these small military pigeons return accurately from thousands of miles away? During home orientation training, handlers help the pigeons quickly adapt to a specific location, establishing it as their home base. After that, no matter where they are released, they will return to that location. Surrounded by natural predators, how do they still deliver confidential messages safely? Pigeons can withstand climbing forces of 3 to 4G, while eagles can only maintain about 1 to 2G. These small pigeons are remarkably capable. They can often escape birds of prey and return safely to their nests. Military enthusiasts visited frontline units to explore the origins of the People's Army's pigeon-based communication system. The program Military Fans Traveled the World recently aired an episode titled Decoding the Battlefield: The Legacy of Messenger Pigeons.